All right, so let's dive in. I'm here in my labs folder and we have the API injection.zip. So I'm just going to unzip API injection.zip, hit enter, and then you'll see that it created a API injection folder. So, whoops, we'll just come into this and have a look, and then we'll just sudo docker compose up. And this should build the image for us if it's not already built, and it will spin up our challenge. And then we come to localhost, turn off our proxy, and we have our lab. And you can see, you might get this message saying test data inserted successfully. This is just the initial populating the database with some products and some users and things like that. So when you refresh again, that should disappear. It's just a little script that I added so that we didn't have to manually set up the database. So first thing I want to do is I'm going to open up Burp Suite, and we're going to do this two ways again. We're going to fuzz for SQL injection using Burp Suite first so that I can show you. And you can do this on the community edition as well. Just know that it's going to be rate limited, so it's going to be a little bit slower. And then we'll do the same thing with another tool as well. So what I'm going to do is when we come to our SQL injection demo, get coffee by roast level, I'm going to follow what I usually follow on any web application assessment, which is I'm going to test the functionality. Usually when I come to a web application, I'll go in and I'll step through everything. I'll send messages, I'll log in, I'll create users, multiple users, and I'll make sure that I understand how the website functions and what it's meant to do, what normal behavior looks like. In this case, we're just going to test this, and we press 3. Or enter 3, and we get a coffee back. So the coffee ID is 5, the origin is Guatemala, and the roast level is 3. And we can check for other roast levels as well. So 4, we don't get anything back. 5, we get 2, so some Ethiopian coffee and some coffee from Indonesia as well. So I'm just going to switch on my proxy, and then we're going to just send this request again so that we capture it. Come back to here, proxy, HTTP history, and we can see the request in Burp Suite. So there's two ways we can do this. One is manual testing, and the second is fuzzing. So what I'm going to do is I'm going to fuzz first. So I'm going to press Control-I, and you can see that I've sent it to intruder, or you can right-click, send to intruder. And then you can see that it automatically detects where I want to put my payload, which is good. I'm going to use the sniper, come to payloads, and then we have a choice of lists. Now, word lists are a personal preference. I definitely recommend testing out different word lists, see what has good results for you, see where their shortcomings are, and even develop your own. So concatenate some word lists together, make some shorter if you think they're too long, and things like this. So we have a few built into Burp Suite already. So we have fuzzing, quick, full, usernames, passwords. And what we want to do is we want to scroll down and we want to come to SQL injection. So you can see that there are a bunch of basic SQL injection payloads here as well. And all I'm going to do is hit start attack. And obviously we're running locally, so it's very, very quick. And if you're on the community edition, this will take some time. And the fact that we're getting all sorts of different lengths in the response, and we're getting some different response codes, so we're getting 401 and 200s, this is an indication that we do indeed have some SQL injection vulnerability. So if we have a look at the response here, we get unauthorized, no coffee found. And if we keep going down, we get, this is just a blank response. And then this looks like we've got an error, which is a really telling thing for SQL injection. If you can throw a database error, the chances are you've got SQL injection. Obviously, in a lot of production environments, you're not going to have error messages switched on like this, or you won't have verbose error messages. You might get something generic back. But the fact that even if it doesn't say fatal error, Uncore SQL exception, even if it comes back saying, hey, there was an error versus your blank payload where there's no error, that could be an indication that we have SQL injection. And it gives us a stack trace, which is quite nice. This is good for troubleshooting if you're in a more complex scenario. And then we also get 1 or 7 equals 7. So this is a good indication that if we look for a coffee where the roast level is 1, or 7 equals 7 is a true statement, if we change this to 7 equals 6, the DB shouldn't return any results. So we're testing for true-false statements, which is a great way to test. And we'll look at that in a second as well. So just looking through the results, you can be pretty sure that we are indeed vulnerable to SQL injection. So let's switch over to manual testing, and we'll come back and we'll do it as though we didn't already fuzz and we don't already know that there is injection there. So Control R to send to repeater. And all I'm going to do is I'm going to send this as my initial request, and I'm going to pay attention. So 159 is the content length, and we get 2 results back. So it's a good idea to familiarize yourself with what a normal payload looks like and what a normal response looks like. So now I'm going to add a single quote, because a lot of SQL queries will use quotes around their variables or their input. And so sending a single quote or a double quote can break the SQL, and that can trigger an error. So this is a really simple way of testing for SQL injection. And you notice that, yeah, we get a fatal error because we've basically interrupted the query syntax and we've broken it, and the database no longer understands this syntax. And we can also do things like where we saw or 1 equals 7 equals 7, we can do or 1 equals 1 to test whether we have true-false statements. So I need to URL encode this because spaces in the request line here are very important. And you can see that we get more results back. So our content length is higher and we get 1, 2, 3, 4, 5 coffees back. And so what we're saying here is select all from coffee where roast equals 5 or 1 equals 1. And because 1 equals 1 is true, it's selecting all. So this is forcing a true statement. And if we change this to, let's say, 1 equals 2, we only get the ones that were originally selected back. So select all from coffee where roast level equals 5 or 1 equals 2. So the roast level equals 5 is the true part, so it's selecting those still, and then not returning the false statement, or the false part of the statement. And we'll use this again later on for the authentication bypass. This is also a technique that can be used when we're dealing with blind SQL injection, which we'll briefly talk about later on. All right, so now we have SQL injection. What can we actually do with this? Well, one attack is union select, and what union select does is it allows us to grab data from different tables, which is very useful as a database administrator. And in this case, I'm going to tell you that there is a users table, and in the users table there are users with a username and password. And so instead of just returning the ID, name, origin, roast level, what we also want to return is union select username, password from users. So it's saying select all from coffee where the roast level equals 5, and also select the username and password from the table users. That's what this statement means. And this actually probably won't work because when you do union select, there is a constraint. You must select the same number of columns as your original query. And you'll notice that here we're selecting 1, 2, 3, 4 columns. And afterwards, we're only selecting 2 columns. So let's run this and see what happens. So I'm just going to encode, Control U, or you can right click, convert selection URL, URL encode key characters. Hit send, and we get this error, which we expected, and you can see that it says different number of columns. Now, if we didn't know the number of columns, we could test, so we could just keep adding columns until we get our result. But if I just Control-Shift-U, by the way, undoes the URL encoding, we can add null and we can add null again. So we're still selecting 4 columns, but 2 of our columns are null. We could also select other things that we want from the table users, such as the ID. So in this case, let's URL encode this quickly. Send this. You can see that we get the coffee back as expected, but we also get admin and the admin's password and Jeremy's password. And if you want to kind of have a play with this, for example, if you change null here, you can kind of see how if we change the query and I put the password into the last column here, the password now appears in the roast level back here rather than in the name. So hopefully that gives you some understanding as to what's happening with the SQL query under the hood. So this is a way that we can go from basic SQL injection to stealing data. And often we'd try and steal things like the administrator password or the password hash, then go and crack it. Or we'd try and steal other data from the database as well. And one last thing to consider is that some databases we can actually get code execution from, depending on the database user, their privileges, and how the database has been configured. Now, I know that's a lot, a lot to take in, especially if you're new to SQL injection. So I highly recommend going and studying a little bit more on SQL injection generally, because it applies just as much to attacking APIs as it does to attacking traditional web applications. All right, so let's take a quick look at fuzzing with FFUF. And all we're going to do is come into here, come into a new tab. And we're going to do the same thing as basically what we did in Burp Suite. So first of all, we actually need this endpoint. So we're going to grab this payload. So /v1001.php. And we're going to go ffuf-u http / localhost, and then, oops, I got 2 slashes here. And then we're going to change this 5 to fuzz. Now, because we have a question mark, I think we're going to need to put this in quotes because Bash may not like this question mark as a special character. I could be wrong. You'd have to check. And for the word list, what we're going to do is we're going to use, I think there is a word list in seclist. So, whoops. User share seclists, and then if we go into fuzzing, and then there it is, SQLi, and then we have some SQLi word lists. So let's go for the generic SQLi and see what comes back. And you can see that it gives us the payload, and it gives us the status code and the size. And again, you can see that the fact that we're getting lots of different status codes and we're getting different response sizes probably means that we have SQL injection. It's not always the case, because it may be returning some value back. It may be saying, hey, this is not a valid request, or, you know, this was rejected. And then if it includes the text within the response, the size may be different as well. So you need to go in and verify that the attack actually worked. But this is a quick way to understand whether a endpoint is likely to be vulnerable or not. And then you can go in, copy and paste some of these into Burp Suite Repeater and test and make sure that it is. All right, so next up, let's take a quick look at SQL Map. And what I'm going to do is I'm going to come into Burp Suite. I'm just going to grab this request, the clean request, the one that doesn't have all of the injection on the end, and just returns a couple of results. Come back here, and whatever text editor you want to use, you can use Vim, Nano, Notepad, doesn't matter. I like Vim, so I'm just going to create a file called req or request.txt. You can call it anything you like. Insert, and I'm just going to paste this in. So if I cat this, you can see it here. And all I'm going to do is I'm going to do SQL map -r for request, and then pass in the request.txt. Now, SQL map is quite a powerful tool, has a lot of options, so I definitely recommend -h, have a look, see what it can do, and do some study. But for today, we'll just have a quick look, and it's going to ask us some questions. So it's saying, it looks like the backend DB is MySQL. Do you want to skip payload for other specific databases? So it's basically saying, I think it's MySQL. Do you also want to test for Oracle? Do you also want to test from Microsoft SQL Server, Postgres? And let's skip because we know that it is indeed MySQL. Do you want to include all tests? Yes. And then it comes back with not authorized. Try to provide the right HTTP credentials. And what we can do is we can just pass this ignore code. It's giving us some good advice there. Oops. Ignore code 401. And then we'll just do yes, yes. So it's really important to read what's happening, and different applications will respond in different ways. In this case, that 401 unauthorized is probably not the correct response code for what's happening with the interaction, but each application will have its quirks, different response codes, different coding styles, different schemas in terms of structure, and this is why manual testing will always be more effective than automated testing. So get parameter roast is vulnerable. Do you want to keep testing others? Let's not test. And then here it gives us some payloads. So it gives us the roast equals 5 and 2373 equals 2373, which we already knew about. We saw the 7 equals 7 in our fuzzing list, and we also tested 1 equals 1 and 1 equals 2. And it also has another error-based payload and a time-based payload as well. And I suspect we can actually just verify this and just go and sleep 10, for example, and it should give us 10 seconds before coming back. And you can see the fact that it hung and hasn't given us a response back does indeed show that we have time-based SQL injection. I'll give that a few seconds. Hopefully it'll come back. There we go, eventually. I think that was a lot more than 10 seconds, I'm not sure. But we got a 401. And again, this is probably the incorrect response code for what we sent it, but each application is going to react differently. And we got a generic union query as well. So here, this is quite a complex looking query, but you can use this as a foundation. So roast equals 5, union selects, and then we can start building targeted payloads based off this. And then one other thing that we can do is we can do something like dump, where it's just going to grab all of the data. It's going to use those identified vulnerabilities, and it's going to spit out the data from the database. So here we have the two users, admin and Jeremy, and their passwords, and we have all of the coffees as well. So SQL Map, really powerful tool, really useful, even if you're just using it for your initial recon to kind of see what payloads might work, and then you tune on that. Or if you use it just to dump the database or try and get a shell, which I don't think this will work, but let's give it a try. PHP. Yeah, unfortunately, because the user on the database doesn't have write privileges, we can't upload a shell. And it tells us that here. So process user has no write privileges, which I did on purpose. The user is only able to read the database. It's not able to insert new data, for example. All right, that was quite a lot to get through. So don't worry if you need to go back and rewatch. Feel free to have a play with SQL Map and Burp Suite and FFUF yourself. Doing is always going to help you reinforce everything you've learned. And in the next video, we'll have a look at a common authentication bypass.